In the last video, I showed a little bit of the GAC, but in this video, I actually want to explore the GAC in more depth. GAC is an acronym for Global Assembly Cache. Hash, like that. When you install the .NET Framework onto a computer, the .NET Framework also creates a global assembly cache, which is a global location for you to store assemblies. And when you use applications such as executables and those sort of things, and they rely on assemblies, as long as those assemblies are strongly named or signed, as we saw in previous videos, and stored in the GAC, then they will be able to locate them globally. However, ideally, if you're just using an assembly that's specific to your application, you do not install it into the global assembly cache. Let me give you an example. Suppose I have bill.exe, and Bill is a farmer who wrote some code that runs against our farm.dll. As I showed in previous videos, we made a simple farm.dll and it simply printed to the console. And let's say Bill, he compiles some code against our farm, and he installs this application of his onto your laptop or your computer, whichever one, desktop, doesn't really matter. If he installs his application onto your computer, then he can privately deploy the farm assembly along with his executable. Now, privately deployed is just a fancy way of saying, hey, he copied the Farm DLL into the exact same directory where the bill.exe file is located. Now he could also copy the farm.dll into a subdirectory of the directory that the executable is located in, but we'll get into that in a future video. For now, let's just say Bill has an executable that's copied onto your computer, and farm.dll is in the same directory as Bill. Now say you have lots of farmer friends that write a lot of code, and all of a sudden you have your other friend called Jerry, and he writes an application executable too, and he loves Jamie's Farm DLL that Jamie created in previous videos, and so his code relies on the farm as well. There's a couple options there. Jerry can copy the Farm DLL into the same directory that he installs his application into, but now we have two copies of the farm assembly. Now, there could be different versions and things like that, but I'm going to ignore versioning in this video. For now, it's the exact same farm.dll file, the exact same farm assembly. Again, the .exe.dll, it doesn't really matter the file extensions to .NET. .NET only uses those extensions when trying to find the assemblies. We've seen how assemblies have four parts of their name, which is the name, the version, the public key token, and the culture, but we'll get into all that later. For now, Jerry exe in one folder, Bill exe in another folder, and two copies of the Farm DLL. Now, this may not be a bad thing. Maybe this is exactly how you want to do it. However, if you do not like the redundancy, and Bill and Jerry are smart and realize Farm DLL, there's lots of farmers writing code against Jamie's Farm DLL. So chances are we should probably deploy Farm DLL globally onto the computer that we install our application onto. So that's exactly what we do here. We do not put Farm DLL into the local directory where these applications are. Instead, we install them into the machine's global assembly cache. And I showed you how to do that in a previous video, but we'll do it again in this video. We put farm.dll here. It's important that the farm assembly be strongly signed. You cannot put a non-strongly signed assembly into the GAC. It must be strongly signed, or strongly named. We sign it to make it strongly named. Sorry, wording's getting a little confusing here. It's a little early in the morning. We sign assemblies to make them strongly named, and thus we can put them in the GAC if we like. Anyway, now when I run bill.exe, bill.exe, we don't have the farm assembly in the same directory as the bill assembly. But .NET's smart and says, well, let's look in the global assembly cache. Oh, here's the farm assembly. We'll use it there. Same scenario with Jerry. We run Jerry. It's, oh, I need the farm assembly. And it just so happens the farm assembly is in the global assembly cache for the computer that these applications are installed on. Let's actually do an example. This code should look familiar. Here's my cow. I have a moo. Version 1, but we're going to not really worry about the versioning in this video. We have console write line moo. And then I have our command prompt that we've used previously. Let me list the contents of the directory. You see I kept my key file around from the last video, but then we have this main class CS, exact same file we have here. And all I want to do is compile this poor lonely cow into an assembly we'll call Farm Dll. So C# compiler, please target a library, meaning a DLL file. Nothing with an entry point. We've seen that in previous videos too. Please make us a DLL. I want to call it farm.dll, and the input file will be mainclass.cs. List the contents of the directory. We now have farm.dll. Let me prove to you that we cannot install this farm assembly into the GAC. I didn't sign it. Remember when I did this C# command, I didn't sign it with my key file. So let's try to actually gacutility. Gacutil comes installed with the .NET SDK when you install the .NET SDK. Gacutility, please install farm.dll. And the gacutility grinds and says, hey, I have failure. I can't add the assembly to the cache. Attempt to install an assembly without a strong name. Got to be strong name. So let's overwrite our farm.dll and sign it. Let's go up arrow a few times, and now I'm going to specify the key file, which will be Jamie's key.strongnamekey. Hit enter, and compiler grinds away. List the contents of the directory again. You see farm.dll is a little bit bigger. Right, now the public key is stored in there, and we've seen that in previous videos. 3,584 bytes, whereas before it was just 3,072 bytes. We gain roughly about 500 bytes there. Now I can say, hey, gacutil, please install the farm assembly into the global assembly cache. Hit enter. Assembly successfully added to the cache. It is now global on my computer. Let's clear the screen here. We're done with this code. Control KC. Let's go down to main class, bring main class in, Control KU. I'm going to save this file away, go back to our command prompt, and hey, C# compiler, we need to reference that farm assembly we just created. And this one's going to be Bill's version, and the input file will be mainclass.cs, or this code right here. Hit enter, compiler grinds, and is happy. Let's do Jerry's code. I'm going to Control L, Control VVV. Let's say Jerry really likes to make his cows moo there. Save this file, hit the up arrow to get the command line back. But instead of saying bill.exe, I will shall say jerry.exe. Hit enter. And now we have bill.exe and jerry.exe. And I want to delete the farm assembly just to prove to you that Bill and Jerry do actually use the assembly in the GAC. But instead of deleting it, I'm just going to, well, why not? Erase farm.dll. And it's gone. List the contents of the directory. Bill, Jerry, but the farm is gone. Let me prove to you that Bill and Jerry actually still work, though. I'll type Bill, hit enter. And Bill uses the farm. The farm came from the global assembly cache on my computer. And let's do Jerry. Hit enter, and Jerry's moo, 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 moo. So there you go. Farm assembly is in the global assembly cache, and Bill and Jerry can still use it. Now, a little bit on probing. I mentioned earlier in this video how if I have Bill's executable, and I have Jerry's executable, and in this scenario, we actually have them both in the same directory. That's this me C# code directory. So they're both there. If I did have farm.dll here, or just the farm assembly, if I had this assembly residing in the same directory, and I also had one in the global assembly cache, we'll say this is the GAC, or the global assembly cache. We do have a farm DLL hanging out there. And these DLLs are identical, meaning their assembly names are identical. We saw in previous videos that a name is made up of the version, the culture, the name, and the public key token. Let's say these are identical, and I run the executable. Which one will be used? You may think that the one that's privately deployed or in the same directory as the executables would be used. .NET would first look in the privately deployed directory, but the rules are when .NET is looking for an assembly, or probing as we call it, if the assembly is strongly named, thus we've referenced a strongly named assembly from the executable, which in this case farm.dll is strongly named, we saw that in previous videos, then .NET will not look privately first. It will first attempt to look for it in the farm or in the global assembly cache. And I can actually prove that to you. Let's go over here, clear the screen, list the contents of the directory. We don't have a Farm DLL anymore, but let's recreate the Farm DLL. I think we're done with this code. We created a few executables from this code. Let's bring this code back in, and I'm going to say this is, I don't know, let's say Jamie's moo, something different, okay? A brand new Jamie's moo, but the version is still identical. It's important that the version is identical. Everything about our new farm assembly we're about to create will be identical, except I just changed up the code a little bit. C# compiler. Or actually, let's just use the up arrow. Up arrow, up arrow. Eventually we'll find C# compiler. Target a library, output farm.dll, sign it with Jamie's key, make everything as far as the assembly name is concerned, make them all identical to the farm that we had before, which we installed into the GAC, hit enter, list the contents of the directory, and again here's farm.dll. Now I'm going to run bill.exe. I don't have to specify .exe, but I will. Bill.exe. I'm going to run bill.exe, and we'll see one of two things. We'll either see the moo code, or moo output that we saw before, or we will see the new and improved, not really improved, but Jamie's moo instead. Now I told you that .NET will first look in the global assembly cache instead of privately. Let me prove it to you. There you go, moo version 1, straight from the global assembly cache. Now, if I uninstall the farm assembly from the global assembly cache, then .NET will still look in the global assembly cache first, but it will not find it there. So then it will default and say, hey, well, do I have any farm assemblies locally, privately, that kind of thing? Let's try it. Gacutil. Please uninstall the farm assembly. Notice I'm not going to specify .dll. I'm just specifying an assembly name. Hit enter. It grinds away a little bit. It says number of assemblies uninstalled is 1. Assembly farm version 1, culture neutral. Public key token. This is the public key token we would see if we looked at Jamie's key. Again, let's clear the screen. And now we do not have a farm assembly in the global assembly cache. I'm going to say bill, run, and we see Jamie's moo version 1. Instead of the moo we had before, we have Jamie's moo. So it located the DLL privately, or the farm assembly privately within the same directory as Bill. Let's just run Jerry for fun. We see Jerry is Jamie's moo, Jamie's moo, Jamie's moo, that sort of thing. Now in the next video I'm going to show you where the GAC is. It's actually, it seems like it's this abstract thing that's on a computer, but it actually has a location, a folder location on your computer. So we'll look at that in the next video.